are better, what platforms are better, and I guess that everyone has their own opinion. Everyone kind of leans towards something they're more familiar with. But talking there about Tableau, and you guys have clearly had a lot of experience working with Tableau. It feels comfortable and familiar and does a lot of great stuff. But what about the likes of Power BI and Click? Does that mean you just never touch that? Or do you still play around with those tools as well? Or?
Personally, I brushed up against Click while I was at EMI, and it was in early stage. I mean, I'm sure it's developed a lot since then, but I haven't really seen it since then, so it's hard to say. Tableau is a very friendly environment, which I like a lot. Click, I only know about it second hand. Power BI I've used more. Be frank about Power BI. It just feels behind.
Right.
It doesn't feel finished to me. So you try stuff and it breaks. It also doesn't have the same consistent feel all the way through it. So Tableau is essentially a pivot table, just on steroids that lets you do some beautiful things and there's a consistent approach to the way that it treats data and the way that it visualizes, where you use Power BI and kind of every chart module does what that chart module does.
Yeah. But
there's no particular consistency. There's no kind of philosophy of data behind it in the same way, and philosophy of this in the same way. So it's fine if it's in your company. You can make nice reports with it.
Yeah.
The little data prep engine behind it is nice. It's probably not the thing to use for kind of really big processing, but it's there. It's fine. I feel like I've kind of picked my favourite. That's kind of where we are. Power BI is alright. It feels a few years behind. I think is the key thing, and that philosophy missing is a big thing for me. That it doesn't hold together in a consistent way in the same way as Tableau does.
And what would you say,
I
Johnathan?
agree. I have not used Power BI really. We have a couple of seats in GHD that use it, but that's on the finance side. I think it's just a legacy system that's been there, and I don't really have any desire to use it really. Tableau for me does everything I need it to do. Does it really well, and quite frankly, you're getting 4 updates a year or something like that. Quite major updates, and they're continuously pushing this product and developing it and making it better. I mean, even just a year or two ago, it was down here, now it's up here. It's incredible.
And how do you think that because they've just been bought by Salesforce recently, is that going to change things? I guess for the better. Yeah.
I hope it doesn't go down. That's all I would say. I hope it continues to do what they do, and I think they seem to do it quite well.
But if Salesforce have bought it, they really position themselves as the CRM tool that everyone should use. Yeah. So they're not gonna buy a pup, are they? They're going to keep it going.
Let's hope so.
Yeah. Okay. Good. When you look at things like machine learning, AI, we as a recruiter clearly speak to a lot of data people that want to go in that direction. What would you say to a data analyst who's on that journey, wants to become a data scientist? What would you say to them in terms of, okay, this is where you need to start?
You need to start by doing, I think, with a lot of this stuff. You've got to try it. Because certainly you've touched on a pet hate of mine there, actually, of AI and machine learning being used completely interchangeably. AI and machine learning.
True.
I think there's the big difference for me. One of them exists and the other one doesn't. So there's no such thing as AI outside movies. There is machine learning. Got to try it. Personally, I got very into football data a while back. Almost as a playground to try stuff. And then you kind of go, well, why don't I build a TensorFlow model with some of this to find out how TensorFlow works? You get into whichever library you want. You try things. Whether that's the drag and drop ones in the cloud and you just want to bounce stuff off and see what happens. But if you've got a basic stats grounding, what they do, there's some really approachable stuff online about how they work. Not the hardcore maths of how they work, but more the feel of how they work. And they're not that impenetrable, really. How image recognition works at a high level is fine. And you can go get a little tutorial and you can build yourself a little engine that recognises cats or cars or whatever whatever you like. So you've got to, I think with all of this stuff, if you're interested, you download the software and you try it. And it's the big difference between the people who learn and the people who don't learn. Is you need to, probably not going to get time at work, so you've got to find something you're passionate about, and go and analyse it at home. And if you want to build a machine learning model, go build one. It's not that hard. Loads of tutorials, like I said. So certainly for me, that's how I got into it. It happened to be through football and mucked about with other bits of data as well, but find a playground and try stuff.
Is that what you found yourself then, Johnathan, just kind of getting into data? It was a case of somebody said, right, we need to do this, and you just kind of go, okay, you probably didn't know how to do it, but you just went away and tried it, and then you learned, and you...
there was a lot of that, there was a lot of that. I mean, going back eight years or so, there was, and even back then there was still a lot of stuff out on the internet if you looked for it, that you could use to kind of to help yourself. I was, there was a situation I described at the beginning. They were quite good with me for the first year. They kind of let me, just kind of learn my own way and get into it. And they weren't hiring anyone else, so I was stuck. So I had to learn from the ground up, basically teach myself. So there was books. Guys like Avinash and Simo Harbour for the technical side, Avinash for more of the kind of strategy and kind of understanding your place in the digital world, and then just doing, as Neil said, you just have to get your hands dirty and get in there and get involved. I see a lot of youngsters coming up and they don't necessarily want to get their hands dirty, and I think that's a problem. You absolutely have to just nail it day in and day out.
Okay.
I would say the one thing I wish I had done through that process was, you quite often talk about data science as this overlap of kind of data viz and programming and stats, and I very much came at it from the stats side, so econometrician. I think a lot of people do that. You come from an analytical background and go, well, I'm kind of learning to code. Is much earlier. I'm getting there now, but much earlier. Going, there are processes and a history to how you code properly, and you can hack for ages, but it's so worth doing the basics of that. The basics of Git and how you structure code properly and how you build packages and functions and things like that. So it's kind of that stuff. I did no book reading on that whatsoever. I just kind of went, I know Excel macros, and dived in and made a mess. And that's the one thing where I would say you can jump yourself ahead by getting a little bit, if that's not your background, coding, by doing a little bit of formal tuition, either book learning or going to a couple of courses, you can save yourself months and months and months of pain by just learning to do things better, quicker. And if you're coming at it the other way and you're a coder, you need stats 101.
Right.
You can't kind of, well, you can get a feel for it in the same way, but it's exactly the same thing. You need university level stats to give you a grounding in how this stuff works and kind of how the actual modelling side works, because you can build beautiful code and apps, but your stats is weaker. And get the formal bit around that.
No, we see a lot of candidates who have that background, whether it be maths, physics, at degree level, and then we've seen obviously a lot of PhD students who have come from 7 years academic background, either in physics or chemistry or biology, and then move into data science, and they're coming straight into the market and calling themselves a data scientist. Sorry, is that right? Do you think do those? Is it harder for a PhD graduate who's got that long academic background to come in to a commercial environment and immediately make an impact, as opposed to a data analyst who's kind of earned their stripes and done a lot of the sort of heavy lifting?
It's different, certainly. I think it depends probably where you're coming into. If you're coming into the Google Google search algorithm and you're being given a very, very clearly defined problem of optimize this better. You know, or I guess I've got no experience with these other industries, but you're going into aerospace and you've got a PhD in aerodynamics and all that. Kind of great, because you've got a very specific problem and the domain knowledge to solve it, and that's fine. If you're going into general business analysis, then that domain knowledge is hugely valuable. And I think, well, you're not going to have it. You know, if you've been an academic for 10 years, you've got other great things, but you don't have that kind of feel for the business world. I was thinking the other day, actually, you can get away with, as I am, being a average coder at best, but an average coder who has very specific domain knowledge in a certain industry, because you can solve problems.
Yes.
You know, whereas I can't build mobile apps, and I'm not a super coder, but you're in a domain where you're kind of one of the better coders in that very specific area, and the better data scientists, and you can make a lot of progress that way. So the domain knowledge is at least as important as ability to do stats.
That's quite interesting. We see a lot of candidates that are either junior data analysts, junior data scientists, ones with just very, very pure academic background, or some that have that programming background. And that's clearly an advantage, isn't it? If you've got that coding way of thinking.
Yes, and we hire for it.
Yeah.
You know, so if you're coming out of university, any young people who might be watching podcasts, learn R or Python.
Yeah.
We absolutely hire for that now. If not that, the ability that we think this person's going to be able to learn it very, very quickly, but we hire for it.
And Python's massively in demand, but it's a language that's been around for a long, long time. It kind of feels like it's finding its feet, really. It's almost the programming language, you know, as opposed to Java or some of the more, I guess, traditional.
It's found a home, hasn't it?
In
data science, and it's suddenly the darling child of the industry. I mean, it's.
Why is that though?
I don't know. Do you use Python more than I do?
No, I don't. I mean, I think it's. I wouldn't say it was on the same level as kind of these artificial buzzwords that we see thrown about a lot. We talked about attribution a little while ago, and how that kind of ebbs and flows with. People get really excited about it, we need it, we've got to have it, and then they realise at some point it's very difficult and you're not really getting too much out of it. With the Python craze, I think people are equating data science and doing amazing things with data science with Python, because they go hand in hand. And if you're doing, if you're hiring someone to do build an attribution model for you internally, you can do it in Python. So you need someone who's very skilled in Python to go and do that. And I think that's where this kind of buzz is being generated about having Python skills. And I think it's founded, I'm not saying it's not founded. I think it's just, we've got to the point where we've got huge data sets, we're working in cloud environments, we've got the ability to really interrogate it with things like R and Python, and we're progressing, we're evolving as an industry. Now we're at that point where we're going, these are now skills that are going to help us. And so that's what's happening.
I think it's from the coding I've done in it. It's a very friendly, consistent language, which I think is possibly what's made it approachable, and it's very extensible as well. So it grabbed onto the machine learning libraries that it has and the data manipulation libraries that it has, and because it's, I guess, clean and approachable. And then it has the data handling plugins. It's a natural place. I'd argue, R is more of a natural home for data in that it's ground up from the ground up rather, a stats language. Moving data around is intrinsic to what R is. It's not intrinsic to what Python is. Python's programming language first, data second. R is data first, and then you've got lots of programming on top. So you end up with, I guess, the ability to make it do almost anything, so it becomes this very, very good general purpose home for all of this stuff. why one took off over the other. It probably is the friendliness of it, you know, and that approach of, I think it's probably fair to say that typically someone with a computer science background encountering R for the first time will raise their eyebrows at the very least and go, what on earth is this language doing? You know, this is ridiculous. Whereas they'll come in Python and go, I really like this. You know, I already know it, I feel at home. So as you cross into machine learning from computer science, it's natural way to go. It kind of doesn't matter. One or the other. They both do very, very similar things. Python's probably got more in the machine learning, certainly more in the cloud space, that it is, you know, all the Google snippets and things are already there for you in Python because their coders use the same stuff, whereas R they're not. Whereas if you do a data viz, R's historically a bit stronger. If you're building apps, like I said earlier, you've got Shiny, so there's easier routes. You know, you either can do either, do anything, but there's a few easier steps in one or the other. You know, if you're doing hardcore machine learning, you're going to use Python probably.
When we're talking to data analysts that want to be a data scientist, what do you think, in your opinion, are the steps, and how long what should a data analyst be thinking about now if he or she wants to become a data scientist in the future?
I think you have to make a decision on where you want your career to go, because if you're going to spend time and effort learning R and Python, then you're going to go down a particular route that is, you know, you're going to be not necessarily in front of clients and looking at top level strategy kind of stuff. You're going to be in the weeds doing coding and data visualization. Maybe you're going to make a lot of money, so maybe, you know, there's ups and downs, but I think you need to decide where you want to go, and if data science is something you really want to get into, then I think Neil said it earlier, you just got to get into it and start doing it straight away. If it was me, I'm teetering on where to go myself. Do I try and upskill in this area? Do I need to at this point in my career? I don't know. But if I was going to, it would surely, probably click on one of those Facebook advertisements I keep getting for 30 days. Become a brilliant data scientist in 30 days. So I'll give that a try and see what happens. Which is a whole other topic, which I find that all very strange. Data scientist courses have sprung up, so it's. I think there's certainly many opportunities and avenues now if you want to go down that route. There's enough out there where you can do it quite easily.
I think that point of deciding where you want to go is really important. I think because we've talked before about the difference between data science and data engineering. It's the kind of that. Are you actually more like a traditional database admin, data engineer? You know, it's all about lining up the underlying data sets, which is incredibly important and what probably more companies need than the data science. Is that you? You know, are you a data viz guy? Are you going to kind of push into interactive visuals and things like that, which is a huge specialism? Are you going to push into machine learning and statistical modelling? Are you going to be building apps? Or I thought that was a really good point. You know, do you want to be down in the weeds of building stuff all day, or do you want to be talking to clients? Because you probably can't do both as much as you'd like to. So maybe you only need, superficial is the wrong word, but more of a passing familiarity with how all this stuff works, so that you can talk to marketing directors and CEOs and people about it knowledgeably, but you're not day to day in a TensorFlow model trying to tune the thing so that it recognises a picture of whatever it's supposed to recognise a picture of. It's such a broad sweep of stuff that you need to pick somewhere. But the start absolutely is getting in and seeing what it does, and then you can start to work out where you might want to take.
And for companies that are looking to recruit and hire people in data, what advice would you give them when it comes to starting this kind of looking at their data in a more scientific fashion? What would be the kind of key first step for any company that's looking to do that?
Can you repeat the question?
Well, I think the thing is for media and advertising, looking at data in a more scientific fashion is a natural thing. It's a given.
Mm-hmm.
But there are now companies that have never really looked at their own data before because they feel maybe they've never had to do that, or it's not been on their agenda. Now all of a sudden it's a thing. To make sure they make the right decisions, what should they be thinking about any sort of business?
Well, I think there's a couple of ways of thinking about that. My top level advice is start slow and start small, baby steps, for sure, and work backwards from what your business problems are and what you want data to help you with. So depending on what kind of business it is, we talked about Morrison's, and maybe they have issues in their supply chain. So okay, we've got an issue with our supply chain. How do we work back and solve that problem with the data that we have?
Yeah.
So you start there and you work backwards. But it's baby steps. Take it easy. Take it slow. This stuff is difficult. Yeah, it's hard. It's frustrating, and it's difficult to find people that can come in and do a job. So there's a lot going on. It's moving very quickly. Yeah, So yeah, my advice is get someone in who can view it from a top level and understand the business and understand the requirements, and then work through the technical challenges of bringing that to fruition.
Okay.
So
I'd agree with that. You see a lot of people want to be on the bleeding edge. It's like we want the very latest, and the trouble with the bleeding edge is it's not easy to work with. It's not established. It's kind of not turnkey stuff. So if you're nowhere, trying to jump to cutting edge machine learning is not going to be helpful. The first thing you're going to find is your data's not all lined up, so you can't actually do anything anyway.
Right.
So that baby steps of can you get your reporting right, which is going to force you to get your data warehouse right, which is going to mean starting to talk to the right people to sort those problems out, and then potentially you can, either from your media agency or or a third party consultancy or whatever, you can start going, well, there might be an interesting little stats project here, let's take another step and integrate it. But there's certainly trying to operate with the mature stuff that works is the first step, rather than I want to leap to some kind of AI optimized thing, because it's so many steps from your Excel reporting workflow to AI optimized business.
Yeah.
It's just it's a chasm, and you want to cross it. Do it in bits.
and ultimately it's just going to frustrate, and you won't go anywhere. You'll waste a lot of money,
Yeah.
and you'll
I'd say the other one on that is anyone who is coming in from outside then saying they have the AI solution to your they just don't. There's a lot of kind of wrapping of open source stuff going on out there, which is sort of effectively free software, and people just sticking a fancy layer on it and going, we have an actual language engine. You kind of don't. You just wrapped a load of. There's a lot of geographic stuff like that. It's kind of, we do this beautiful geographic analysis and mapping, and if you've got the right analyst in, they can do that for free.
Yeah.
Whereas you're buying an expensive platform, so be very wary of the bleeding edge platforms that claim to solve all the problems, because they largely don't. Back to reporting where we started. You buy a bleeding edge reporting platform, it's only got to not talk to one of your data sources, and you're in real trouble.
Yeah.
Sort of a turnkey, it just does everything, except that affiliate that we're running over there, and now I can't get that affiliate in my reporting, and this whole fancy system isn't working.
There's always affiliates too.
It is always affiliates, because there's millions of them. But so the fancy solution only has to not do one or two things. Whereas if you're building it in blocks and building some knowledge in your business and your department, you can solve those problems. If you're just saying, we'll throw money at this third party to solve it, if they don't solve all of it, you're stuck.
What do you see then as the biggest challenges for a media agency over the next, let's say, 5 years?
Everyone's going in-house.
No, on trends like that, actually, it's a really big thing. It's interesting you say that. There's a lot of trend towards kind of digital in-housing now. Rightly in a lot of cases, I have to say, because when you're talking about you want to integrate it through your website properly and your website's in-house, you want as few barriers in that as possible. So yeah, we're talking a lot about how we not attempt to stop that trend, but how do you shape yourself around it and work with it and all that. That's a really big one.
I think it's funny because I think data and analytics is a strange one. I was at a Google thing a couple of years ago and they were talking about this topic, and the suggestion was that things like paid search and SEO are moving in-house, but things like data and analytics, which if you ingrain yourself with a client in that way, with their data and their analytics, and you become like a holder of that for the client, if you like, it's then much harder to move that in-house because you've built up such a big core kind of team, people handling your data and analytics in this agency. It's very hard to get away from that.
Yeah.
So that's good news for at least for data and analytics.
No, I think that's fair. Certainly when you try and take above the line, so telly, radio, press, media modelling in the house, it's incredibly difficult because there's very few people who have that kind of base knowledge of how that works, and it helps to work across a lot of clients, and it helps to see the problem over and over and over again. It's something very often I've seen academics struggle with actually, where you go, I can build a regression model so I can explain what TV's doing to your sales line, and you go, yeah, not unless you've done it 5 or 10 times before, you won't, because it's not as simple as that. You build your model and it just doesn't work.
Yeah, and you've been there, done it, hundreds of times, hundreds of clients. So you've probably made a lot of those mistakes.
Yeah.
Time and time again to learn from them and get it right. But
you've got a head full of shortcuts. Because I know what telly generally looks like in a sales line. I know what I'm looking for. Whereas if you're coming into it cold, you don't have that background of shortcuts. You'll get there, but it's going to take you an awful lot longer.
Yeah.
Whereas an analyst who's done this again and again and again, but getting that analyst into your business who's done it again and again and again is difficult. Is where.
And that's still a big challenge for, I guess, any advertiser that's on TV and is on radio and press. How is that offline media driving digital traffic? How are people getting to my website? Is it this TV advert? Is it this radio? Is it a mixture of all of that and the out of home and everything else? That still must be a huge challenge for you as an agency.
That's econometrics.
Yeah.
30 strong team in London doing that, and it still exists. That's why we're right back around.
Is it getting better? Is it getting easier? We met 5 years ago and it was a challenge then. Is that still an issue? Is it still a challenge for you?
The data flows are getting easier.
Yeah.
You can do it faster. You can repeat it better. The core problem of can you point a machine learning algorithm at the sales line for a company and say, tell me, in a clean and consistent and you're not going to go wrong way, how my media are driving that line? No.
Yeah.
You still need an analyst to do it. There's not an algorithm that will do it. There's some really cool algorithms that will put you in a ballpark in a way we didn't used to be able to. So we can take a Google traffic line and media activity and kind of throw it into the box and go, put me in the right ballpark for what marketing ROI probably is, and it will do it mostly. But the kind of we're getting it right to within a couple of percent, and we can really explain why this line's moving now. We still need an analyst to take it apart.
I have a love-hate relationship with attribution, and ultimately we're trying to put numbers against moments in someone's life that affect how they're behaving at that particular time, and that's super difficult. And I don't think that challenge is really spoken about enough, because what made you decide to buy that product? Why did you click on that? You can't put numbers to that, really. Yes, there's some great stuff going on, and there's a lot of helpful data. I'm not saying there's not, but ultimately, we have to be very careful.
It's still back to if we're doing something, it's better than nothing.
I agree, and I 100% agree.
Yeah.
It always ends up with like we're quite heavily caveated, and we have to take this into consideration and that into consideration. All that.
There's also, we were talking about it just before we started filming, that there's still a big space for doing it the old-fashioned way. Of you can have all these fancy, media ROI attribution algorithms and econometrics and all the rest of it. And in the end, one of the most reliable ways to find out whether something's working is turn it off for a bit. It got literally, and Google now are pushing that. They've made some tools to help us to do that more easily. So, you don't have to destroy your whole pay-per-click campaign. You can turn it off in a city and watch that city.
Yeah.
You can do it on a small scale. You can do it with the display ads. You can run some ads which are gifted to a charity. So you're getting a data stream for what ads do when they're not actually advertising your company. Do they look like they're selling product or do they not?
Yeah.
And there's a huge space still, even amongst all the clever algorithms, for well-structured testing strategies where you turn things on and off and turn them up and down and see if anything happens.
Yeah.
You need to monitor them, right? But in the end, that's the best evidence. That's if you would publish it in a medical journal, you'd be doing testing control on a cohort of people, and you would give some the medicine and not others, and that's still the best evidence we have.